Okay, well, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us. I'm Trevor Edels. I'm CEO of iTechEd Limited. We're a mainframe consultancy analysis and technical authoring organisation. We're responsible for the content on the virtual IMS website, and we produce the newsletters, etc. And if you want to know where the website is, it's at iteched.com/virtual IMS. And we also look after the virtual CICS user group too. So first of all then, let's run through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation. And today our guest presenter is Nick R Griffin, Worldwide IMS Specialist at BMC Software. His talk is called Reach the IMS Database 4/8 gig line. Now what? And a copy of the slides from this presentation will be on the website later today. And by the way, if you've missed any of our previous meetings, you can download copies of the presentations from our website and you can listen to them again. There'll be a link on our resources page. So following Nick's presentation and any questions you have for him, we'll move on to the latest IMS news, latest IMS related articles. Feedback requests is there to remind me to ask you for your feedback about this virtual meeting, and then I'll give you the dates and times for the next virtual meetings. So that's the plan for the meeting. I'm anticipating that it will last for, well, under an hour. Anyway, as I just said, today's presentation is from Nick Griffin. Nick has over 45 years of mainframe experience in development, systems and database administration for IMS, MVS, KIX vSAM and VTAM applications. Nick has been a developer for IMS monitoring code and managed a development group for a competitive software vendor. Nick managed large, complex, mission-critical IMS database applications for a variety of Fortune 500 companies, and most recently he spent 14 years as IMS product manager for a large tools vendor. And Nick is currently assisting sales as IMS product account manager. So Nick, I'd like to thank you very much for being with us today. And what I'm going to do now is pass control over to you. So let me just do that. Okay, you should have a message on your screen.
There we go.
Yeah, I can see it. Good.
All right. Well, Trevor, I appreciate it. Thank you for inviting me to present again. I must have done a halfway decent job last time, so you allowed me to do it one more time. Yeah, you know, it's 45 years seems like a long time, but man, it sure has gone by fast. So I know there's quite a few of us in the same boat, and we're planning on hanging around a little while longer. So look forward to meeting more of you people that are joining the IMS team. So as Trevor said, this presentation's basically called, "Hey, you've reached the IMS database 4/8 gig line. Now what?" And it's kind of like the magical line in the sand, right? And it probably, for systems people, they don't think much about it. It's more of a DBA situation, but even systems people, if your databases are hanging up and your transactions aren't running, you're going to start hearing about it as well. And so that's why I started looking at this. So I pulled this presentation together mainly based on questions I got from a number of customers who were starting to experience problems with database size. They'd call and say, "Hey, what can we do? How do I get around this? I'm not sure if, I want to go HowdyB, or I don't know if I want to do this. I'm not sure which way to go." And so I've talked to several of them, and they've gone different directions, which is fantastic, because that's really the nice thing about IMS. It gives you lots of options, and we've worked very hard to make a lot of options in the IMS area. So it's very available to you to make a decision on the best way for your business to go. And so I created this, and it's kind of a high-level presentation. We get down nitty-gritty a couple little places, but I try to keep it high level because this is a presentation to help you think about my alternatives and what I can do. So this is the agenda that we're going to go through today. The first part of the agenda is we're going to talk a little bit about what the issues are, and then we're going to come back and kind of discuss the alternatives. So I've got a number of alternatives here I'll talk to you about, and we'll kind of hit through those as we move along. So is space the final frontier? And of course, I'm not talking about some of our Trekkie guys or anything like that, but I'm talking about DASD, our database space. And sometimes it is kind of our last frontier. It's it's where we're headed down the road. Nowadays space is very cheap. You can buy the little racks of DASD, and you can put a lot of space out there. But oddly enough, what I've found is a lot of these companies that they just don't do that for legacy systems, which kind of surprises me. But if you got a big data project, it seems like, wow, they're all over that. They'll throw space at it left and right and have data lakes and all kinds of stuff. But for us mainframe guys and legacy system guys, it's hard to get space sometimes. But that's not always the total problem. It's not how much space you got, it's how much you can utilize. And so that's what we have to look at as well. So here's a list of data that was generated in a single day, and I don't think it's any big mystery to most of us that data is growing. And here it shows mostly new technologies, and they may appear to be kind of outside of the legacy systems that we deal with. But it's one of those things. Data is growing. I hear it from all of our customers, and all these things that you see here, you may not think they affect your data, but they do. Because if Facebook is growing, if tweets are growing and emails are growing, there are things that means more people are utilizing the systems today than they ever have before. And that means they're on doing things that may be coming through the web or through TCP/IP or some other means that's going to affect our legacy systems one way or the other. So we know we got to be prepared for that. So I pulled up a couple examples, and I know these are pretty relative today. This one that you see here is an example of a data growth which happened, mainly due to the coronavirus. It shows how people can really overwhelm a system, based on immediate demand. In this case, a number of banks, reported outages, and it was due to increased volumes of transactions that were coming in. It was just that they were getting a whole lot of transactions all at once, people checking their accounts, looking for their stimulus checks, which we did here in the States. I'm not sure if we did that if other countries did that as well, but they were just overwhelming the systems with transactions. And like we know that 95% of all the banks in the world run on legacy systems. And somewhere close to 90% of them are IMS. So we know that we're being affected by these huge amounts of transactions and huge amounts of volumes, which can cause us issues. Another one that I wanted to mention, which happened kind of around the same time frame, was with the New Jersey workman's comp system. They ended up running out of space due to increased new applications, and by applications I mean people that were having to go in and create an application for a system, not a data application, which we're kind of familiar with. But for some of you that aren't U.S. based, workman's comp is one of the systems that our states handle in order to handle paying people that are gotten furloughed or dismissed, and they can get a certain percentage of dollars while they're trying to look for jobs. So it's one of those things that we went from at the first of last year to about 7% unemployment, went up to over 20% unemployment. So you put all those people out in the system, and they're trying to get onto these workman's comp systems, and they're just deluging the data that's coming in, they're doing so much at one time that it just totally blew up these systems. And this particular one I thought was kind of interesting because they wanted to go in and rewrite to fix this issue so they wouldn't have it again in the future, not knowing where we're going down the road. But all of a sudden they ran into a different problem. They found out that COBOL programmers were non-existent and they weren't able to bring in a bunch of people to fix their problem. So they put out a message on the news and asked for help, and there were a number of people that came in, came out of retirement. They came out of retirement to help them to resolve their issue, which I thought was kind of interesting because I'm sure these people made some money real quick and went back into retirement. But that's not dissimilar to the problems we have in IMS. Our IMS skills are very short, and if we had a problem and needed IMS skills right away for a lot of projects, it might be very tough to have happen. So the next thing I want to talk about is database space itself. I realize that most people in this session are fairly knowledgeable of IMS, and I'm sure there's some people in this session that may have been forced into the world of IMS like I hear about. I've done a couple of sessions which were internal with customers, and come to find out that there's 4 or 5 people sitting there that are either DB2 or Oracle DBAs that are having to learn IMS because they don't have a choice. So I kind of wanted to talk a little bit about what database space was and a little more understanding of IMS itself. So an IMS database consists of one or more data sets, which allows IMS data to increase as free space decreases. Once the primary space is used up, you get an out of space condition. And that occurs when there's no secondary that was allocated. Now, when there is secondary space allocated, then the data set will expand until you get a data set full or an extent full or extent resource used up condition. And so out of space, can actually cause many different problems that you may see as you move as data continues to grow. Other out of space causes can be due to extents. You may not have enough data set extents or volume extents. Hopefully these days it's not a problem, but it can still happen. Or there's just totally no space on that DASD volume at all, and you've just grown as far as it can go. But those are kind of various ways that you see out of space and outages that occur with out of space. But in the IMS, we have an IMS limit, which is a size limit on databases. And for most of us in IMS, we know that you can only have either 4 gig or 8 gig. And once you run out of that space, there is no extents. There's nothing you can do to add on to that to make that happen. And of course, here I'm talking about full function databases. But when you reach that, IMS just stops processing. That's as far as he'll go. He won't do anything else. You got to go do something with that database, and nothing else will happen. No other transactions will run, and your customers are now sitting in an outage situation. So when IMS uses all the data for the first time, it formats the data in what's called control intervals. These blocks are inside and they're allocated space that the data set can use within the data set that can be used by IMS. So the space is formatted by IMS, and that's called unused space. Immediately after the space is formatted, these control intervals or blocks contain no data whatsoever, which means they're only consisting of free space. And when the application starts running and inserting and replacing, doing replace operations, then you start taking up that free space. So as those segment data are stored, that operation continues with the application until it reaches a max size. And as you can see, there's an allocated area, there's a used area, there's a max size of the database. And like we said before, if your VSAM is 4 gig, if your OSAM is 8 gig, and that's the way full function works. That's as far as you can go with the database. Now you can't add data sets and you can do things like that, but you're still limited to the amount of space you can use. So let's go over the alternatives one by one, and as you can see, I've listed a number of possibilities that you might want to consider. Those possibilities are do nothing, change to a full function, change from a full function to a HowdyB, or maybe a Fastpath or a PDF, or you might even want to implement some type of compression. So let's discuss each of these and kind of see what these alternatives are. Of course, the first one is do nothing, and oddly enough, I've heard this recently from a customer. I was talking to them, and they said, "Well, we're not going to worry about it right now." And I have to be honest about this. I see it all the time, and I'm probably as guilty as anybody of procrastination, right? So let's don't do anything unless we just have to, and probably in more ways than one. I hate to admit that I procrastinate, but I just do, and we just don't want to do anything unless there's no other alternative. So when space becomes an issue, what we do is we try to figure out ways for someone else to do something to resolve it, and then we just kind of put it on the back burner. But we need to know what the actual alternatives are to resolve this in case it becomes a disastrous outage for our application. I mean, none of us want to have to resolve our problem in the middle of the night, and that could be what happens. So I like to say do nothing is more or less not a good plan, but it is a plan. But you could always do it yourself, or as I like to say, do IT yourself, kind of a pun on that for us IT people. But as a DBA, we usually push this off to application teams to resolve. We'll ask them, just, hey, go archive a bunch of data or figure out what you can delete, and we can get ourselves back down to 80% or whatever number we can live with for this time, and then we'll just continue to do that. But some of these records are they're only kept for historical purposes, and maybe that's good, but maybe it's not. Maybe you need some of these records to be sitting there for auditing reasons. There may be information that a customer wants to go historically back and look at immediately. Your customer wants to look at. So one of the issues in this approach is somebody has to take the time and to make decisions on what gets archived or what gets deleted, and they have to do that on a regular basis. The customer I was talking to, they actually, at first, they were doing this on a monthly basis. And then as things kind of went along, they added some more information into their database, and the next thing they knew, they were having to do this twice a week. They had an application guy that had to sit there and determine exactly what records they could let go of so they could continue using the database. And when you think about it, that's a lot of resource, time, and money that's being wasted doing that type of information. So is it really a sustainable alternative? I don't think so in the near future. I think it's going to be kind of problematic. But if you're only doing it once a month, maybe it works for you, and it is an alternative. So it's one thing you need to think about, and I'll leave it at that. It's something you could do for quite a while. So let's talk about moving from like a full function database to HowdyB as an alternative. Of course, HowdyB was introduced in IMS version 7 back in August of 1997. And HowdyB supports 1,001 partitions with up to 10 data sets per partition, which allows you to have 40 plus terabytes of possible space for your data. That's incredible. That's a huge amount of data. And so hopefully it'll never run out again, but I'm sure there are people that get close. But it supports 4 gig for vSAM and 8 gig for OSAM, and your partition sizes depending on which way you want to go, which one you want to use. The one thing I will note is if you decide to go the 8 gig route, the HowdyB online reorg, which comes with IMS, doesn't support that OSAM 8 gig size. But all the vendors, us included, we have online reorgs that do support it, so you can easily get by that, and that's not a problem. One key that I always like to say with HowdyB that is a requirement you have to think about is that all your partitions must be registered in DBRC. So it's something you have to think about. I know a lot of customers that don't use DBRC, and as much as I make statements to them that that's not a good idea and they need to be using DBRC, it's just the way their processes are set up, and they feel comfortable that way, and they're going to continue to use it that way. So I don't think it's a problem for me, but it could be a problem if you don't like using DBRC. So HowdyB is made up of a master database with multiple partition names. Each partition requires a specific high key. This means that if you have keys 1 to 20, the partitions must be in the order of the key specification. So it's just, you can go to each one, you can call a key and go to that particular partition, or you can just read sequentially down through the partition. So it's very easy to manage. If you're going to separate it out, there are other things you may have to do, but it's pretty simple to do. And you set all this up by using what's called a partition dataset utility, and that can be found. IMS has it available for you, and all the information you have is now stored in the recon, which is really good. So this is just a simple example of if I move from a full function HDAM database over to a HowdyB database. It would basically look the same. I've got an HDAM that has 2 data sets. My HowdyB would now have to allocate basically a couple of data sets per partition, and they would have an A and B along with an indirect list data set, which is needed by HowdyB. And then you just keep multiplying that number by the number of partitions that you would need. So you can keep expanding that out as far as you would need, up to 1001, right? Which could be quite a bit of space, but you may not need all that space. So you don't want to allocate it right off the bat. You just allocate what's necessary and what your future needs are. So here's the HowdyB migration process. But before I go through that, I want to talk first about what I feel like the need for a migration tool is. I mean, I really think that everybody needs to use a migration tool. It's highly important if you're going to go as a DBA and do this work, and you need to have something in your hands to make it easier for you to do. IBM has a PMR with migration tools in it. All the other vendors have some type of migration tool as well. These tools, what they do is they allow you to determine what the optimal ranges are for your record keys so that your data is distributed evenly across your partitions. They'll help you establish your partition boundaries. Then they'll help you generate all the required DBRC and IDCAM type statements that you need in order to allocate and set up your databases. So that makes it much, much easier when you're trying to do the work. At BMC, we have a GUI tool that we use, and we call it Maximum Database Advisor for IMS. And it helps also simplify by utilizing what we call wizards, which are actually workflows that will guide you through the step-by-step process of doing that type of redistributing work or allocating, and it does all the information is built for you and finalized JCL. So if you're not really a IMS DBA and you're coming in from a DB2 side and you need help, this will walk you through that. And that's what hopefully everybody will do down the road. We'll have simple tasks to get you through these. So now back to the migration process. The first thing you need to do is you need to unload the full function database, and you can do that with any number of vendor tools that have just base unload utilities. You'll need to save off all your DBRC information. It's highly important to do that, and you can do that using a DBRC command called recon.backup. That way you have a backup of that information. And then, because you never know about fallback. I always say I'll never happen to me, but I've had it happen so many times that you want to be safe and make sure that you have a way to fall back. And that's why I think it's always a good idea to do an image copy before you start anything. Make sure you have a complete image copy of your database, and that way, if something happens in the middle and you have to fall back, you've got an easy way to do that. Then you want to delete the full function database information. You need to delete all that out of DBRC, and you can do that by using a delete.db command, which will delete everything from the recon. I know all the old database history is going to be obsolete and it's going to be gone, but you need to clean it up before you move to HowdyB. Then you need to delete all the objects that are related to the DBD and the NBA member, because now you're going to need to create brand new ones. You'll define the HowdyB by making the necessary DBD changes. Your DBD is now going to be PH down or P high down, and you'll have a PS index in there as well. So it's going to be different. It's not going to be the same DBD you used before, but the basics will be there, and you'll just have some different type names. So then once you've defined the HowdyB to the recon, you can also do that by utilizing a procedure called DFS HALDB, or you can use the DBRC init commands. Those would be like a init.db and init.part, and those commands can be used to define the HowdyB that you're going to utilize. So once you've done all that work, the next thing you want to do is you want to load the HowdyB into IMS, and you can do that with the same type of vendor utility, which is a load utility. You'll need to run index builds for any of the secondary indexes you want to have, because that won't happen automatically. You'll have to do that yourself. And then after all is done, you want to make sure and do a final image copy of your new HowdyB data sets, so that all the information is now stored in DBRC and you're completely authorized and ready to go. So that's kind of your migration process to get through HowdyB. So here are some of the differences in HowdyB versus full function database. I won't go over all of them, but I will note a few items that are no longer available. So if you need to do shared secondary indexes, that's not available. Non-unique keys, symbolic pointers, or logical relationships. Most logical relationships aren't available either. You'll need to kind of research through these before you get started. You don't want to get into this and realize that, oh no, I needed unique keys or non-unique keys, and I can't do that anymore. So make sure and research your database before you get started on it, and then you should be in pretty good shape. And as you can see, there's some other numbers up here that the database is going to grow a little bit, but when you think about it, so you go from 4 to 8 bytes on the EPS and so forth. If you've got up to 40 terabytes, that should not be an issue, right? But in considering what your partitions are going to be, and you're trying to allocate certain sizes, you'll want to have that as far as when you're doing your calculations. So here's some of the pros and cons of moving to HowdyB. Naturally, one of the first ones is storage capacity. We know that it's going to increase dramatically, and that should help you a lot, and that's what you're looking for here. The availability of one data set database can be held to only one single partition. You can do that as well. Secondary index databases with direct pointers, you don't have to rebuild when you're doing the index databases for the reorganization. Logical relationships, the ones that you can use, those are updated pointers. Those are good. And then the reorganization to a single partition, which I think is highly important. If you have 100 partitions and you only have one that seems to be needing a reorg, you can reorg one at a time without a problem. And then the one pro is, no matter what you do down the road, IMS catalog is going to require you to have at least one HowdyB database within your system. So you might as well start thinking about that as well. Some of the cons that you're going to have to think about is, it does require some application changes. You have to think about how you're going to utilize your applications. You may not have to do very much at all, but most people I've talked to, once you start doing partitions, you start thinking about different ways to handle data and spreading it out. And so your applications need to be aware of that. That may be something you have to do. One of the big ones I talked about a while ago is DBRC has to be in every IMS environment. That includes test. So if you have testing procedures, you may have to think about how you're handling, that environment. And the others are fairly important, but I think that's one you're going to have to take a look at. And I know that a couple of vendors have ways of doing non-DBRC and test, which is mainly batch testing. So you could look at that, but it is a little bit more work to get set up. So the next thing I want to talk about is the Fastpath, and maybe using Fastpath as an alternative. I know it's something most people won't think about, but Fastpath is not a bad database structure at all. And if your database can meet up to the needs that Fastpath can allow, it can actually be a very good database structure to utilize. So the term Fastpath basically speaks for itself for you guys that hadn't been out there in the IMS world for a very long period of time. It is a shorter path than full function to help speed up processing. We'll talk more about that in a second. But it was introduced, basically at the request of financial institutions. IBM brought it out in 1977 at an IMS level 1.1.4. Sounds like a long time ago, right? It supports 2,048 area data sets, which is a little over 8 terabytes. Now that number is being increased to 9,999, which should be coming around fairly quickly, and that'll get you over 40 terabytes of data. That's equivalent to what you can do in HowdyB. Now each data set is limited to 4 gig, so there is no 4 and 8 gig separation here on Fastpath. You can only do 4 gig. The one thing about Fastpath is DBRC is not required for Fastpath. Now, of course, I'll continue to say this over and over, but I highly recommend that you use DBRC for any database types you do. But if you feel the need that you don't want to, Fastpath doesn't require it. So one of the keys to Fastpath is the support of full online reorg with concurrent update capabilities. That means that no outage is required unless you need to do some type of schema changes, which I think that's what most of us are looking for. We're going toward 24/7, and we're going to think about that down the road. This is highly useful that you don't have to have an outage. And even if you do need a schema change, almost all the vendors now have a capability to take that down to a very minimum outage of just minutes. The problem we've always ran into with Fastpath is once you try to make a schema change, kind of like HowdyB, you've got to bring all your areas down, make the change to every area, and then bring them all back up. But with some of these vendor products, you can do it area by area, which should speed up the process. So let me go over the aspects of Fastpath, and I'll go through this kind of quickly. But first, we talked about the path length. It is significantly lowers CPU, so that's highly important. You got less CPU being utilized. There are a number of techniques that are introduced in Fastpath that reduce or eliminate I/O. Fastpath uses sequential dependent segments, and they're stored separately from the roots, and they're in an entry sequence manner at the end of the area. And what this does is it's designed for data entry, for very fast insert capability. Then you also have high-speed sequential processing, which can benefit programs that do large volumes of physical sequential processing against DEDBs being data entry databases. And they can be very beneficial for read-only, but also for update jobs. Fastpath allows you to have subset pointers, which creates a subset of the twin chain to enable applications to access the subset without having to process down through the twin chain from the beginning. Another thing Fastpath gives you is virtual storage option. This reduces the read I/O, which decreases the locking contention and creates more effective read and write areas. Another one is main storage databases. We don't hear a lot about them anymore, but they were very highly used a number of years ago. But all the data is in main storage. There's no I/O at all. So you just they have to be in a root-only database, but it makes it very quick, which can reduce the amount of amount of time in the I/O. So there's a lot of things that, and as we continue down the list here, that Fastpath can do to make it much faster, less CPU, and make it much easier to use your data. And one of the good ones down at the bottom is log reduction, because we're seeing a lot of different logs, a lot more logs these days. So this is a picture just kind of depicts a general picture of what Fastpath would look like, having a multiple set of areas. So when you initialize Fastpath, it's kind of the same way as HowdyB. You have control intervals, and they're created for internal use. But the root addressable part is divided into what we call units of work, which is the basic elements of space allocation. Then there's the independent overflow, which contains empty control intervals that can be used by the unit of work area in the area, and then the sequential dependent parts that holds dependent segments also within the root area. So you kind of see how they're kind of spread out a little bit. Now, once you decide to create a DEDB or data entry database, you need to decide on what the segment distribution will be. This is highly important because it helps you calculate the average database record length. This in turn helps you decide, a couple of different things: what the CI size and what the unit of work size are going to be. Those are things that are not easily changeable. Once you decide that, you're kind of stuck with them, and it's very difficult to make a change on those. So once you pick the CI size, you must decide, unit of work, and it has two parts, each comprising of a number of CIs. And so you tell it which ones what numbers you want. And then IMS stores, data into the SDEP segments in different parts of the data set, and that dependent overflow allows IMS to use the data in each CI before it runs out of space. And he can use the dependent overflow to be a logical extension of those base CIs. Now, there are some extender vendor products that actually allow you to extend that space without having to do anything. But those are products on the side as well. Now, first, after you define the DBRC, then you have to initialize the database, and then you're ready to load your data. So when should you use HowdyB full function versus DEDBs? Well, there is no support for logical relationships or secondary indexes in Fastpath. Now, secondary indexes, we've kind of solved those. Even IBM's put it in IMS, so that's not really a big problem anymore. But your application, if you need to process things in root segment and key sequence, you won't be able to do so as well. DEDBs, you need to be using randomizers to help with root anchor points. Buffers are not a problem anymore since we have introduced 64-bit buffers. That's usually not a problem for you. But if you have databases that have short records, that's just wasting space within your database, so it's probably not a good idea. And some people have more than 127 segment types. That's not possible within Fastpath either. Fastpath does require you to use vSAM, so if you want to use OSAM, you're going to need to use HowdyB full function databases. So let's talk about another kind of partitioning alternative real quickly. For us, it's called the Partition Database Facility for IMS, or PDF. But it was originally delivered in the market in 1997. It was developed by Neon, who BMC bought. And it was developed for IBM to market as a product called IMS ESA Partition Support Product, or PDB. And IBM started utilizing that and then realized, well, hey, we probably need to develop something else. And so HowdyB was developed. And PDB became really kind of an unnecessary product. And IBM gave it back to Neon to sell and maintain. So Neon then maintained it as PDF. And then, like I said, a few years ago, BMC bought Neon and picked up the PDF product. PDF supports 127 partitions. So you can add up to 1 terabyte of storage on your database. It includes support for HiSam, SHISAM, and OSAM 8 gig databases. And it doesn't require DBRC, but like I keep saying, it's always a good idea to do such. The implementation for PDF is very simple and requires no application changes, which I think is highly important for many smaller customers that don't really have the applications people available to go out and make any type of changes. So kind of like you saw with the HowdyB, PDF requires a database name with many partition names below it, and the attributes are set up by what we call a part selection routine. And then all of that is registered within the recon. And much like the HowdyB, you basically have one DVD, and you make changes to your DVD by adding what we call partition names to it, which is a very simple task. And you can add as many as you want and allocate the databases or data sets, and then keep adding to it. So you have one data set in a regular HIDAM. You can just add this partition name to your DVD, and you can keep adding partitions as many as you need down the road. Now, PDF migration is fairly simple. You unload the database just like you would with what we talked about with HowdyB. You add the part statements to the DVD, run your DVD gens, your ACB gens. Then you do your notifications for DBRC if you're using DBRC. You need to update your MDA lib because now you've got more data sets that need to be allocated when you bring your database up. And then you load your partition, build your secondary index, image copy it, and alter any JCL you may have because you may, if you're doing a reorg and you got one data set, you may have more data sets now you need to reorg from. But that's really all you got to do, and you're ready to go. So the primary pros and cons, well, it extends your database with very little effort, and you can add multiple partitions. It's very transparent to any applications or PSBs, so batch really doesn't know the difference. You don't have to change any batch performance. The performance is actually better. You can improve performance by doing this, reduce contention, and so forth. And it supports indexing as well. So a quick summary is, it's straightforward. It's business as usual. You don't have to make a lot of changes. Testing programs don't change. You can keep your testing the same. You don't even have to use PDF over in the testing side. It's a very small learning curve, and it implements within less than a week, and you're ready to go. Pretty simple to do. So the last alternative I want to talk about is compression. And most all of the vendors have compression capable products that can help you through compression, but I'm going to talk primarily about ours. I had a customer actually tell me that they got 85% compression utilizing the compression routines on their database. And that's a phenomenal amount. I think usually what I see is somewhere between 50 and 60. And it all depends on how your segments are set up in your database. But you can have a much longer life with your database by just compressing the data, and that's really the key here. So if I compress it down 60%, then I've got that much more life that I can go on with the database without having to alter and make any changes. It reduces the logs. It has better hit ratios on your buffers. So there's lots of improvements that you get, based on I'm pulling in a 4K block size, and now I'm getting a lot more data in that 4K block. So we have what we call Data Packer for IMS at BMC, but the other vendors have compression utilities as well. Ours uses about 8 different compression options, static Huffman, and so forth. We can support space management like minimum segment length and fixed pad size. Those are important things to a lot of customers, and free space segment size. One of the things I want to mention real quickly is we have a trial utility that you can use, which takes samples of your data and can tell you about what your compression percentage will be and how much CPU you'll use. So it's a very, very great very good at utility to bring up and test your database with to make sure it works fine and you compress. You can use it directly on your database, or you can run it against an image copy or unload offline. And it only needs about 20,000 records. It doesn't need a whole lot of data to tell you how much percentage you'll get. So real nice utility to utilize. As I said, implementation is just adding information to your DVDs, and that's really it, and you're kind of on your way. So the keys to compression is you don't want to double compress, and we handle that, and we tolerate non-compressed data if you want to have compressed and compressed data in the same database. And there's really no registration required, and it's a fairly simple process. So I ran through a few of those, kind of running a little short on time here, but a lot of things to consider, and hopefully you got a little bit out of this presentation and saw that there's some things you can do for alternatives, and hopefully this will help you think about it down the road, because we know that no matter what, our data is going to grow, so we need to be prepared with those alternatives. I also added a page here, and you can pull up, these are the resources that I utilized to build this presentation. Of course, naturally, I didn't think of all this myself, but these are the URLs where you can go out and get greater detail on each one. And at the very bottom, I had somebody, I did this presentation before, and he said, well, you have this best practices for HowdyB that Peter Armstrong did. And I said, yeah, I know, and it's hard to find, but if you really want a copy of it, just send me a note, and I'll send you a copy of that so you can have it. So, Trevor, I think I ran a little long, but hopefully everything went well, and I think we're ready for some questions.
Yeah, no, don't worry about time. If anyone's got any questions, then if they can just type them into the chat, and I'll ask Nick. Or if anyone thinks of any questions afterwards, they can email me, or they can email Nick.
Yes.
If you send them to me, I'll forward them to Nick, and I'm sure he'll get back to you fairly promptly. Can't see. Trouble is, I can't see if anyone's actually typing anything. All I can see is when someone's actually pressed the send message.
Well, like I said, my email address is at the bottom of the previous page. So give me a shout anytime you need something. If you have a question or need some help, glad to help.
All right. Well, I think I will move on. So I will say thank you very much, Nick. That was a great presentation. Good recap on a whole load of things that I certainly thought I knew, but when you said them, I realised that I didn't quite. So that was really good. Yeah. And because we're a virtual user group, as usual, then please assume we're giving you a virtual round of applause at the moment. So thank you very much for that. Okay, I'll just take control back. Oh, here we are from Karen Tischer. FP is online only. She says, can you mention that? Oh no, she says, can I mention an upcoming class?
Well, Karen, you always want to put in a pitch for it. So go ahead.
Someone's saying, will you send us the presentation by email? The presentation, Scott, sorry, Eric, will actually be on the website later today, so you'll be able to download it from there. Oh, and Scott Quillisi then has said he sent you a text, so can you check your phone for a text from him?
I got it. Thank you, Scott.
Okay, yeah. Right, so Karen's saying, yes, IM 1097 HowdyB at Themis Inc. on February the 23rd, one day. Right, okay, thank you all very much for that. We'll move on. And yeah, thanks again then, Nick. Let me make myself presenter. And yes, we might even have you back again, Nick. So right, I'm just going to share my screen then. There we are. Let's. Oops, sorry. Yeah. So news. We've got IMS news. Infotel has announced version 2 of its ECOX application parallel testing (APT), which was designed to quickly spin up developer testing containers on a mainframe. It runs tests in parallel, allowing developers their own sandbox to test and release iterations of their code. ECOX APT can find all the components of an IMS or KIX transaction with a click, and all programs and tables that transactions users are cloned in a test container. Mobile applications and internet development teams can create their test tracks of all the IMS or KIX transactions required and work completely independently of the mainframe developer teams. There's a link to that story on our website. Okay, articles then. We've got quite a few. There's Assessing IBM IMS OSAM Encryption Performance by Jasdeep Singh, which is on the IMS part of the IBM Z and Linux One community. We've got A Simple Way to Enhance IMS Database Dynamic Segment Layouts by Carlos Alvarado, again in the same IMS part of the IBM Z and Linux One community. We've got Understanding How a CMO SL1 Input Message Sent to IMS Connect Works in the Case of a Client NAC. That's by Subhashi Sarkar, and that was on Tech Channel, the new website. We've got Data Privacy for Diagnostics, Securing Diagnostics for IMS. That's by Sanjay Kaliyur, again on that IMS part of the IBM Z and Linux One community. And by the same author then, we've got IMS Support for ZOS Workload Interaction Correlator, and it's in the same place. And lastly, we've got Pushing the Limits of Modern Security Pervasive Encryption for IMS OSAM Databases. That's by Sanjay Kaliyur again, and in the same place. Links to all those articles are on our website, so you can find them from there. As always, can I ask for feedback about this meeting? Again, you can email your comments to me. My address is on screen, or you can use the Contact Us webpage on our website. So let's have a look what we've got planned for the future. Our next meeting is on the 13th of April. We've got Thomas Esser, Z Solutions Architect, Director, IMS Solutions Advisor from Rocket Software, and he's discussing saving CPU time with IMS database administration. And then the meeting after that's on the 8th of June, when we've got Al Soret, Gary Euler from Maintegrity speaking. And I haven't got a note of what they're talking about, but it does say on our website, I know that. So that'll be quite interesting. Just a reminder that you can keep up to date with what's happening in the world of IMS and on the Virtual IMS User Group website by following us on Facebook and Twitter, and by joining the Virtual IMS group on LinkedIn. And there are URLs on screen at the moment, but they're all on the homepage of our website. If you use hashtags, then the hashtag for us to use is hashtag Virtual IMS. And everyone likes likes, so if you do go to Facebook, it'd be nice if you liked us. Okay, that's all for this meeting of the Virtual IMS User Group. Can I thank you all for attending? Thanks to Rocket Software for sponsoring our user group. And of course, I particularly want to thank Nick Griffin for today's presentation. So that's it. Thank you all very much for joining the meeting. And I look forward to seeing you on the 13th of April. So thank you all, and goodbye.